Hi, this is Mrs. Robleski again. We're just reviewing for the benchmark on how to solve systems. We went through and spent a lot of time on substitution, elimination, graphing, equal values, and how to find a place where the two lines intersect. Sometimes they don't intersect and we end up with no solutions, and other times they intersect every single point and we have infinite amount of solutions. So we're going to go through and review those as well. So here I want you to just have a piece of paper, follow along, write down some notes because you are able to use these then on the benchmark. So the first one I mentioned, I kind of give you some hints as to what you might want to use. Again, on the benchmark, I don't tell you which method to use. You're going to use the one that makes the most sense for you and makes the most sense for the problem. So over here, I look and I see that I can solve it using substitution because I know y equals 3 minus 2x. So I can go ahead and put that over for y and go ahead and solve it that way. I could use elimination where I see this is all, well, almost lined up. The y's are lined up. These are not lined up, so I'd have to move that over here and put the negative 2x plus the 3, and then I could use elimination. Or I could go about graphing it and figuring out, okay, where would I start my y-intercept and what would be my slope then, and graph it. So you can choose any method at this time. I want you to pause the video and figure out which method works best for you and see if you can figure out what the solution is, if it's infinite, if it's no solution, or if it actually is a x comma y coordinate point where they actually intersect. So I want you to pause the video, go ahead and do that, unpause it when you are ready to reveal the answers to yourself. All right, we are back with the answers. I'm going to show you all the methods. So over here, I figured out that this was y and this was y, so I kind of substituted their equal values. And I look and I add 2x to both sides. I end up with 3 on one side and the 3 on the other side. There actually is no x anymore. When I look at that, I end up seeing that, yes, 3 does equal 3. That's true. If it's true, if the statement is true, that means it's going to be an infinite amount of solutions. So I'm going to write the word infinite. If you use elimination, you can see that the y's cancel out, the x's cancel out, and the 3's cancel out. So you end up with nothing on one side and nothing on one side. And that might have confused you a little bit to have nothing on one side, but 0 does equal 0. Again, it is true. If it's true, it's an infinite. Now, some of you are going about this saying, well, that's kind of silly to do all of that work when I just look at this and I say, well, this is the starting point, my y-intercept, and this is the slope, and this is the slope. If they have the same slope, they're the exact same line, they would intersect at every single point, and that is true. That is why this would be an infinite amount. So we're going to go through another one, and I want you to figure out if it's infinite, no solution, or has an actual solution. So I just want you to pause your video when you get a chance. I'm giving you a little hint about elimination. You don't have to use elimination, but again, graphing this, I'd have to get it into the y equals mx plus b in order to figure that problem out. So I might go through elimination. So pause the video, and I want you to go ahead and multiply to get the same coefficients and try to use elimination to see if there is an answer to this one, or if it's no solution or infinite. All right, so you should be back. You should have noticed that the 3x you could definitely get to be 9x. All you'd have to do is multiply everything by 3. So I went ahead and did that. I end up with 9x minus 6y equals 3. When I start eliminating, 9x minus 9x gives me 0. And even these are the same. Negative 6 minus the negative 6 does equal 0. So I have no x's, no y's, and I don't even have a number over here because 3 minus 3 is 0. So 0 equals 0 is true, which means that it is an infinite amount of solutions. So I want you to go ahead and continue on pausing and trying these videos that I'm going to go through. So I'm looking at this next one. Again, I'm giving you a little hint about solving and using substitution, elimination, or graphing. If you have graph paper, great. If not, some of you can just kind of pick out, oh yeah, this is going to be my starting point, my y-intercept, that will be my slope. And you look, the slopes are ending up to be the same. They're the same, but do they start at the same spot? No, one starts at positive 9 and one starts at the negative 9. That means they are going up at the same rate, but starting at different places. That means they're going to be parallel. If they are parallel lines, that means they will never, ever, ever touch. So over here, you can see that these lines are never, ever intersecting. They're never intersecting. There is no solution. So I would write no solution to this one because they will never intersect. If you didn't want to go about graphing it, again, you could do going over here and see the y equals. You could take this and substitute it in, and you would end up with 5x minus 9 on one side and the 5x plus 9 on one side. You subtract 5x and you get negative 9 and 9. The x's are gone. Well, negative 9 does not equal 9. It is not true. It can't happen. So we end up having, it does not ever happen. If it's never happening and it's never touching, it is no solution. We're going to go through and I want you to pause the video as you try this next one. All right, now that you've had some time to work through this, I kind of like the graphing. It looks pretty easy. I just look and I say, oh, the 3 and the 3, those are going to be going up at the same rate. They're starting at different points. That means they're parallel. If it's parallel, it's automatically no solution. Those of you that chose to maybe eliminate, well, if I eliminate, there's 0 on this side, and 1 minus 2 is a negative 1. That can't happen, so then I end up with no solution. So if I take a look at this last one, well, maybe 2 more. Solve using substitution. I look, y equals 8x minus 2. I can substitute that in for y. And I want you to go ahead and try to figure out what that one is, if it's infinite, no solution, or has a solution. All right, I am back and I am looking. When I substituted it in, I end up with 8x minus 8x is nothing. Negative 2 on this side and a negative 2 on this side. That is true. Negative 2 and negative 2 equal the same thing. So that means it is infinite because it is true. Those of you that chose to graph it, this was already in this format, y equals 8x plus negative 2. That's my starting point. That's my slope. This was not in the y equals mx plus b, so I need to get it into that format. And when I do that, I end up seeing that this is the exact same slope, the exact same y-intercept. If they're the exact same slope, exact same y-intercept, they are the same line. They are an infinite amount of solutions. Last one that we're going to go over and try, then I want you to pause the video and see what you end up getting. I want you to try using elimination. So pause the video when you are done. And coming back and looking, it looks like 8x I could get to be negative 8x. So how I would do that, I multiply everything by 2. So I go over here and I multiply all of that by 2 and I get negative 8x plus 2y equals 16. This gets eliminated. Negative 2 plus positive 2 is nothing. So I have nothing on this side, and 16 plus 16 is 32. If nothing does not equal 32, and it can happen, that means they are never ever going to touch. So we write down no solution. So on your benchmark, you might end up having something that looks like this where it can't actually happen. Then you're going to write no solution. If it can, you're going to write down parentheses, the x and then the y. Or you might actually just have an infinite where it always is true. So you can use your notes on the benchmark, and hopefully that will be very helpful to you.